Solid-state materials are commonly grouped into three classes. We have insulators, semiconductors, and conductors. Insulators are materials which have almost no conductivity. Glass and rubber are examples of these. Conductors are those which have almost full conductivity. Gold and aluminum are examples of these. So what is a semiconductor? Semiconductors are materials which have conductivity between insulators and conductors. Semiconductors can be pure elements and can be compound. Elemental semiconductors include germanium, antimony, arsenic, boron, silicon, and tellurium. These elements are basically found from group 3A to group 6A in the periodic table. As what I've mentioned, semiconductors can be compounds, include gallium arsenide and indium antimonide. Semiconductors are classified into two categories. We have intrinsic or pure semiconductors and extrinsic or impure semiconductors. Extrinsics are further divided into two types, the p-type and n-type extrinsic semiconductors. Intrinsic semiconductors are chemically pure form of semiconductors materials formed by tetravalent atoms. Tetravalent means 4 valence electrons in its shell. Intrinsic semiconductor. Extrinsic semiconductor are basically two types. The first one is n-type and the second one is p-type. So what is doping? Doping is the process of adding impurities to intrinsic semiconductor to alter their properties. In equation, pure plus impurities is equal to impure, and we know that impure is the intrinsic semiconductor. The purpose of adding impurities in the semiconductor crystal is to increase the number of free electrons or holes to make it conductive. So in doping, n-type and p-type are called dopants. N-type is donor dopants. It is formed when 5 valent impurities are doped by contributing extra electrons. P-type is acceptor dopants. It is formed when 3 valent impurities are doped by producing hole or electron deficiency. Semiconductors is sometimes referred to as integrated circuits or microchips. These are complicated mechanisms found in almost all types of electronic devices. Let's take a look at wafer manufacturing, specifically how semiconductors are made. The production starts with silicon. Silicon is commonly used as semiconductor materials in electronic industry as it has proven to be an effective semiconductor. The main advantage of using silicon is that it is rich in supply, being the most abundant element in nature just after oxygen. The first step in the manufacturing process is actual production of wafer. In this process, purified polycrystalline silicon is heated to a molten liquid. As the silicon is slowly pulled from the melt, the liquid cools to form a single crystal ingot. This process is known as Czochralski method. The cone-shaped ends of the ingot are cut off while the body is sliced into thin wafers of uniform thickness. Surface grinding produces low-cost and highly quality wafer than its counterpart. Lapping and etching. It removes the damage inflicted by the slicing process and used to remove the selected portions of material from the wafer. Polishing and cleaning. Polishing refers to finishing touch to the silicon wafers. Wafers are ready in lithography process. The flawless surface allows the circuit patterns to print better on the surface of the wafer, and this will be the result of macro chips. And thus, semiconductors are foundation of modern electronics and are at the heart of microchips. I hope you all understood about semiconductors. This is Nahida Ansari from STEM 12 2.